So again, always put the a term, ax squared term here, negative 36 here. And we want to figure out what multiplies to the product of those two, which is negative 36x squared, but adds to 9x. So we have negative 36, but a positive 9. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. So we want to figure out which of those two could subtract to give us a 9. So I'm thinking 9 and 18, right? Because those are 9 apart. So let's see if that works. 9 times 18. No, that's not going to give us 36. So that's not the right one. Well, let's look at the answers, right? We either have 12 and 3 or 9 and 4. So I know 9 and 4 are not going to add or subtract to 9, right? It either would give us 9 plus 4 is 13 and 9 minus 4 is 5. So I already know those can't be the answer, but 12 and 3 are the other two. If I had a positive 12 and a negative 3, 12 minus 3 is 9. So that definitely works. So if you ever get stuck, just take a look at the answer choices. It's giving you their factors, right? It's giving you options, and there's only 2 options that they're giving you. So kind of test them out and see which ones work, and that'll save you a lot of time. So now we're going to put 12x and negative 3x. And we're going to factor the greatest common factors. So from this row, we can pull out an x. They have 2 x's here, right? And 1 here. So we can pull 1 out. From the second row, we have 12 and 36. Well, 12 times 3 is 36. So I know 12 goes into 36 3 times, and 12 goes into itself. So 12 is my greatest common factor. For the first row, we have 2 x's and another x, so we can pull out an x, right? And then from here, there's 2 negatives, so I know I'm pulling out a negative. I can pull out negative 3, so that means we have x minus 3 and x plus 12. Oh, wrong one. So now let's put that into Desmos. X minus 3x plus 12, then x squared plus 9x minus 36. I'm going to zoom out to see what this looks like. Okay, there's my parabola. And then x plus 12x minus 3. And they are perfectly on top of each other, so our work is correct. All right. Last one. Ms. Triggs thinks that f of x equals x squared minus 6x plus 8 could be the function graphed above, I should say below, because they both have 2 negative zeros. Is she correct? What are the zeros of the function? Well, the function is this guy. And Ms. Triggs, myself, is claiming that this has 2 negative and this has 2 negative. This certainly has 2 negative, right? Because they're on the left side of the x-axis, that's where everything is negative. So we need to factor this to see if I'm right. So if we factor, we're going to put x squared here, 8 here. So then what are the factors of 8? So what multiplies to 8x squared but combines to make negative 6x? Well, the factors of 8 are 1, 2, 4, and 8. 2 and 4 make 6, right? This is one of those special functions that we talked about before, where if we have a minus and then a plus, right, ax squared minus bx plus c, this means that it's always going to be a factor with 2 negatives. Just one of those things we have to remember. Another way of thinking about it is like, okay, we have positive 8, so it has to multiply to positive 8. So a positive times a positive makes a positive, or a negative times a negative, right? So when we're confronted with this situation, I'm thinking to myself, well, it can't be this because this is negative. So I must have to choose 2 negative numbers. And if they're both negative, they're going to kind of add to make negative 6x, right? So that's how we arrive at 4x and 2x, or I should say negative 4x and negative 2x being our answers or factors. So the other weird thing about this type of pattern is that we always are going to pull out negatives when there's a negative. So what do I mean by that? With the minus plus, you want to make sure that you're pulling out negatives because both of these are negative. So let's just walk through this and I'll show you what I mean. It's a little hard to explain. So from here we have xx and then negative 2 and x, so we can pull an x out. From here we have 4 and 8. I know I can pull out a 4, but I'm going to make sure it's negative. If we pull out something, it'll be x and then negative 2. So x minus 4, x minus 2. Let's say we'd made the mistake of pulling out positive 4, though, and positive 2, which makes sense because that's been what I've told you to do, right? I've told you if one is negative and one is positive, pull out a positive. This is the one situation we don't do that. So now this is where Desmos comes in handy. Let's plug in the function x squared minus 6x plus 8. Okay, and let's say we made the mistake first, being x plus 4, x plus 2. Right, we're seeing they're not lining up on each other, right? And so that should prompt you when you're checking your answer, oh, maybe this is the one Ms. Triggs told me about, where instead of pulling out positives, we pull out 2 negatives because of this funny pattern thing. And you'll see that that quickly reconciles the issues. But that's not the full answer, right? The question is asking, am I right in saying that the function and the graph both have negative zeros? Well, this one's tricky, right? We know that x minus 4 and x minus 2 is the correct answer, right? We saw that on the graph. So if we solved these using the zero product property, right? X minus 4 equals 0, x minus 2 equals 0, and we use inverse operations to isolate our x's, we're going to get 2 positive zeros, right? So no, I'm not correct. this graph has 2 negative zeros. The function has 2 positive zeros, but I could see why the mistake was made because this is a confusing problem. It's one of the unique ones where we have to memorize these certain rules. So no, I'm wrong. So let's just get rid of anything that says yes and figure out which of the 2 no's is appropriate. No, she's incorrect because the function has 2 positive zeros, which are x equals 2 and x equals 4, while the graph has 2 negative zeros. That sounds right to me, but I'm going to read the other one just in case. No, she's incorrect because the function has 1 positive zero and 1 negative zero, which are x equals 2 and x equals negative 4. False, right? We got positive 4. So now I know that that's not the right answer, and therefore A is the correct answer.